In this lesson, we're going to focus on interpreting the line of best fit. The line of best fit is the line of best fit makes a prediction. In other words, it tells us what to expect for the given situation. So these are great things to put in your notes. Okay, the slope represents the rate of change. We're going to be working with slope quite a bit, so this should be a review. Remember, slope is the change in y over the change in x. So when we're looking at graphs, we have an x-axis and a y-axis. So a lot of times we are able to look at the slope by looking at the change in y over the change in x. So when you're looking at the graph, you specifically look at the words along the y-axis over the change in the word along the x-axis. Okay, so let's look at some examples of what that looks like. The example, Brianna's math teacher plots student grades on their weekly quizzes against the number of hours they say they study on the pair of coordinate axes and then draws the line of best fit. So they plot the points and then just draw a line kind of through the center to see where the center of that data is. What does the line's y-intercept represent? So we're looking at the y-axis to find the y-intercept, where that hits. We can see that the y-axis represents quiz scores, okay? So, and then the x-axis represents the amount of time spent on homework per week. Okay, so bottom is time. The y-axis is quiz scores. So what does the y-intercept mean? What does it mean here when 0 hours are spent studying? Okay, so 0 would be what was over here along the x-axis because you go 1, half an hour, and back means 0, and up to between 65 and 70. So with 0 hours spent, you would get around the score in between 65 and 70, possibly lower. So let's look at what our choices are. The change in expected quiz scores for every additional 1 hour student spends on their homework. So is that going to show us the change for every hour? Not sure. The prediction of a student's quiz score if they spend 1 hour on their homework. Well, we really talked about this is probably 0 hours. Here's 1 hour, so that one's not going to be a good one. A student's expected quiz score if they spend no time on their homework. Well, wasn't this representing no time because we have our 1 hour, our 2 hour, our 3 hour, our 4 hour, and then each half hour in between there? Or how many hours the student spends studying all year. Well, this was worked up in hours, so that all year is not a good fit for what this data is representing. So we're just really looking at the graphs and what the data points are representing, and specifically on the first section where it represents on the y-intercept, which is where it hits the y-axis. So I'm going to say I agree that it would be the student's expected score if they spent no time on their homework. Yep, which is correct. Okay, let's look at another example. Amelia decides to research the relationship between the length in inches and the weight of a certain species of catfish. She measures the length and the weight of a number of specimens she catches, then throws them back into the water. After plotting all her data, she draws a line of best fit. Okay, what does the slope of the line represent? So look at our graph. So we see that the y-axis is representing the catfish's weight. The x-axis is representing the catfish's length. Okay, so she plotted points. So if we look specifically at this fish, so a 26-inch fish weighed about 16 pounds. Because this is in pounds. So each of these pieces of data represents something. So we have a 29-inch catfish weighing at just under 25 pounds. That's how we figure. And then they drew this line in here. So each of these data points represents a catfish, and then they drew a line in just the center. And they want us to tell them what does the slope of the line represent. So how do we find slope? Remember, slope is your change in y over your change in x. Okay, and you can point that from any, if you want to find your change in y, then you can go to over the change in x, so rise over run, remember. So you're rising up the change in weight over the change in length. Because remember that when we found slope, it was rise over run, which is the change in y over the change in x. So in other words, the change in the rise is the weight over the change in the run, which is the length. So that's the interpretation. You could specifically use 2 different points to calculate that, but we're not actually going to calculate the numbers. We just want to know what the slope means today. So let's look down here at our choices now that we better understand that. We're specifically looking at what does the slope of the line represent? Does the slope represent the expected length of a catfish that weighs 1 pound? Probably not. The expected weight of a catfish that is 1 inch long? No, that isn't even on this graph. The rate of change, oh, that's right, slope means rate of change in the expected length of the catfish over its weight. Length, is it run over rise? No. The rate of change, yep, slope means rate of change, is expected in the weight of the catfish over the length. So weight over length, rise over run. Yes, those words are falling in there. All right, so then we can see they plotted the change in y, which is the change in weight, over the change in x, which is the length. So your weight went over your length. And then they broke this down where the change in y is over, which is the change in expected weight, over the change in the length. Okay, so you align your y with your words and your x with your words. All right, one more example coming up. Okay, so next we have a scatter plot and a line of best fit. Remember, the line of best fit is the line that's drawn through the dots of the scatter plot. The scatter plot is just the dots with points plotted to represent data. Okay, so the scatter plot and line of best fit below show the length of 11 people's femurs. So each one of these dots represents a person. And the length of their femur. What's a femur? It is the long leg bone in the thigh. That comes right back to health in learning that. And their height in centimeters. So then that's the person's height in centimeters. This is the length of their femur bone. What does the point 55, 193.6 represent? Okay, so what does this represent? So we know that the x-axis is representing the femur length. So the 55 is going to represent a 55 centimeter femur. And the height, and we just talked about that this is 11 people's femur. So these points must represent people. So this is people's height, and it comes up to 193.6. So this person's height is 193.6, and the femur is 55. Okay, so now that we've really looked at that scatter plot and thought about what the words mean, go ahead and read through these choices and decide what you would pick. Pause and then unpause when you think you're ready. All right, so I would have picked the height of an actual person with a femur length of 55 centimeters is 193.6 centimeters. Okay, the height of the actual person, they told you that that is the actual person's height if they have a femur this size. Okay, good. Make sure when you are reading through the feedback on Delta Math that you always read, because there's a lot of very important information in here. It does tell you that X represents the femur length and Y represents the height. So the 55,193.6 represents the actual height of the person with a femur length of 55. All right, nice job. Okay, so work through your homework and work until you get several correct. If you have any questions or need additional help, please let me know.